Welcome to part 2 of case study ex2, where we'll continue to show how to apply key operators in Project Reactor's mono class. Part 2 of this case study will show many of the same operators we looked at before, as well as some new ones that will be used once again to demonstrate how to reduce, multiply, and display big fraction objects asynchronously. An operator for handling runtime exceptions is shown, and we also show yet another way to handle both fully asynchronous as well as hybrid synchronous asynchronous processing to carry out the computations. As always, you can find the link to the code we're going to walk through at the bottom of the slide below. We're now inside of my IntelliJ project for case study ex2. Let's take another look quickly at the ex2 class, which is the entry point into this case study. If you recall, in part 1 of this case study, we talked about the first two methods, test fraction reduction async 1 and test fraction reduction async 2. We're now going to take a look at 3 more methods: test fraction multiplication callable 1, test fraction multiplication callable 2, and test fraction multiplication error handling. Test fraction multiplication callable 1 is going to test a hybrid asynchronous big fraction multiplication model using a mono and a callable, where the processing is performed in a background thread and the result is printed in a blocking manner by the calling thread. Test fraction multiplication callable 2 will test asynchronous big fraction multiplication using a mono and a callable, where the process and the printing of the result is handled in a non-blocking manner by a background thread. So it's done entirely asynchronously. And then finally, test fraction multiplication error handling tests big fraction multiplication asynchronously using a mono and a callable, where the processing and the printing of the result is handled in an entirely non-blocking manner by a background thread, and exceptions are handled gracefully by using one of the error handling operators defined in the mono class. As always, all these tasks are run in the context of the async task barrier framework, which runs them in the background and then waits for the results to finish before returning to the main thread. So let's go back to mono EX. We've talked before about these fields, the unreduced fraction field, the scall field, the block time field, and so on. And let's skip down here and get into the meat of the new methods we're talking about now. So first, we're going to talk about test fraction multiplication callable 1. As we always do, we create a way to hold the intermediate results that we're going to be generating. And in this case, we're going to be using a string builder, not a string buffer, because all the printing is going to be done in the calling thread, in the main thread. So we don't need to worry about race conditions. Here's what we do. We go ahead and use the from callable factory method operator to take the scall field, which, as you can see, is going to take 2 big fractions. It's going to create 2 big fractions and multiply them together. And this from callable will then run in a background thread that's created by the single factory method on the scheduler's utility class. So that processing takes place in the background. And then we're going to call another operator that's a blocking operator called block optional. And what block optional is going to do is it's going to block the calling thread until the result's available via the mono, handling any errors via an optional. And of course, optional is a class that was introduced in Java 8, which can either have a result if it was able to compute the result, or if there's no result, it's what is called an empty optional. So it's a way of not having to deal with null references in Java and the dreaded null pointer problem, an exception. So this will block the calling thread. The actual multiplication will take place in a background thread created from the single factory method. And then when we're all done, we're going to go ahead and use the result map method. So map will only call the to-mix string conversion operator if, in fact, we get a valid value in the optional. Otherwise, we're just going to print the string error and store that in the appending to the string builder. The final thing we do here is we go ahead and display the string builder as a string and then return the empty mono, indicating that we're done. So this is an example of another hybrid model where some of the processing is asynchronous and some of the processing is synchronous. Let's go ahead and take a look at test fraction multiplication callable 2. In this case, we use a string buffer because a lot of the work is going to take place in the background thread. And in this model, we once again use the from callable factory method operator with this scall callable. Just to remind you what that does, it's going to multiply those 2 big fraction objects together. That will also run in a background thread that's obtained from the single factory method on the scheduler's utility class. And then we call the do on success action operator in the context of that background thread to display the mixed fraction in the string buffer. And then we use the then operator to terminate everything, indicating to the async task barrier framework that the asynchronous computations are done. The third and final method we're going to look at in part 2 of this case study is called test fraction multiplication error handling. And as you can see, what we do here is we're going to create another callable, but this callable is actually going to be called bad call. And the reason for that is we're going to create two big fractions, one of which is going to be a numerator and the other which is going to be the denominator, but we're going to make the denominator have the value of 0. Well, that wouldn't be a problem if we weren't also going to then divide the numerator by the denominator. So in that particular case, you can imagine we're dividing the numerator by 0, which of course is going to throw the arithmetic exception, and crazy things will happen at that point, of course. To handle those crazy things, we're going to define ourselves an error handler, which will be a function that takes a throwable and a mono that's parameterized with a big fraction. And what this error handler is going to do is it's going to append the exception message into the string buffer rather, and then it's going to simply convert the error to 0. So we're just going to omit big fraction 0. Maybe not the best way of being able to handle this exception, but you'll see how it gets used here when we look at the actual chain of operators on the mono below. So here's what we do. We go ahead and use the from callable factory method operator, passing in bad call, and we know that that's going to throw arithmetic exception. We do that computation in the background, once again using the single factor method on the scheduler's utility class to subscribe that to run in an asynchronous manner. Then we go ahead and plug in the on error resume operator, and that passes in the error handler. And what that's going to do is that's going to convert the arithmetic exception we get when we divide by 0 to the value 0. Then we go ahead and use do on success, which will print out that big fraction of the value 0. And then we use the then operator to wrap things up and indicate to the async task barrier framework that we're all done. So let's go ahead and take a look at what happens when we run this code. We've already looked earlier at test fraction reduction async 1 and test fraction reduction async 2 in part 1 of the case study. And now let's go ahead and see what we get with these other calls. So here you can see we end up computing the result here. Notice this is in the calling thread. This is the main thread. That's because we use that block optional call. So the computation took place in the background, but we waited for it in the calling thread, and that's why it comes out of thread 1. Test fraction multiplication callable 2 did all the computation in a background thread, in this case, thread 20, and it gets the same result, of course. And then here's the results that we get from test fraction multiplication error handling. You can see that we had that little print message that says we're trying to divide by 0 because the fraction denominator is 0. And then, of course, that on error resume error handling operator converted the exception into the value of 0. And so we end up with a result of 0. And all that takes place in a background thread as well. And as we talked about before, all 5 of these tests completed successfully. And so you can see that the async task barrier returned a 5, indicating that was the number of tests that ran and didn't have problems. So that's the end of the case study for ex2. I hope you learned some interesting things about some more advanced mono operators.